going to go ahead and get started here. So, good afternoon, everybody. Thank you so much for being here. Welcome to our November 2024 installment of ENERCALC Office Hours. Everybody who's here probably knows by now we have transitioned from our sessions platform to using Zoom. So, we have just a couple of quick housekeeping items before we get going on today's program. So, I want to start with a quick sound check. If you direct your attention to the bottom menu of the Zoom window in your browser or desktop app, you can see the chat tool or the reaction emojis down there. If you're able to hear me right now, just go ahead and throw a thumbs up emoji in the chat. Give us an okay, give us a hand, give us a reaction or like of some kind. Make sure that you guys can hear me all right. Again, if you can hear me, just give us a quick reaction and we'll make sure that our audio is good. Perfect. Looking good. Okay. Thank you guys for verifying that. Before we get on to our other items, I want to also go ahead and do a sound check for our other speakers. So once again, if you can hear Mac's voice when he says hi in just a moment, go ahead and throw us a thumbs up or an okay, and let us know that you can hear Mac.
Hi, everyone, and welcome to Office Hours.
And again, you do have your own audio controls, both on your local computer and within the Zoom options. So you should be able to raise the audio in the session if that audio is too quiet for you. All right, now that we have our tech checks out of the way, we are going to go ahead and disable the chat and we'll move on to some introductions and get going with today's program. So my name is Seth Roseworm. I'm a senior structural engineer and software developer here at ENERCALC. Our presenter for our monthly ENERCALC office hours is Mac Elterhony. Mac is a senior structural engineer here at ENERCALC, and he kind of splits his time between providing technical training for ENERCALC customers, working with the ENERCALC engineering team on the specifications and technical behavior of our software, and then also helping maintain a national presence for ENERCALC at various events throughout the industry. Mac is also founder and managing principal of Elta Design Group, which is a specialty structural engineering firm based in Oklahoma City. And he's been an ENERCALC user for about a decade, so he definitely has a lot of great insight about the needs of our customers. So for anybody who's new here this month, ENERCALC Office Hours is meant to provide direct line of communication between us and you guys, our customers. It's meant to do multiple different things. Mainly, we showcase new features and update you guys about what's the latest, greatest in ENERCALC. We also show optimized workflows for your design calculations. We answer questions that are submitted ahead of time in writing. We also do live Q&A, hands-on examples, and then if there's ever a question that's too involved or requires a lot of deep digging and research, just be aware that'll be a better fit for reaching out to our support team so they can investigate your concerns, look under the hood. As a minor point of order, you will notice that everybody's microphones are muted just to make sure we don't get any echo or feedback during our program today. And as I mentioned, we do have open Q&A at the end of each session. So if you want to submit a question, if you have a question that comes up during the session today, just go ahead and use the Q&A dialog in your Zoom window to submit that. If you experience audio problems at any point during the session, if you're in the browser, you can refresh your browser or close out and rejoin the session. And you also have onboard audio controls here inside the session. If you ever want to rewatch today's program or any of our other monthly ENERCALC Office Hours programs, you can always access those from the Office Hours playlist on our ENERCALC YouTube channel. So with that, I will go ahead and hand it over to Mac, who's going to get going on our program for today.
Thank you, Seth, for the introduction. And again, welcome everyone to another session of our monthly Office Hours program. Let's go ahead and start today by having a brief overview of the overall agenda of today's session. So we will be covering ENERCALC latest build, register for office hours to get notified, what's new in ENERCALC, ENERCALC for Revit, and the live Q&A portion. So we have a couple of housekeeping items. We have a couple of items that we want to discuss. So are you on the latest build of ENERCALC? If you open ENERCALC and look at the very top, you will find your current build that you're on. And we want to make sure that you get notified of any new updates, so you're always taking advantage of the newest features that we implement. And we do have updates monthly. So there's a lot of features and a lot of work that gets taken care of on a monthly basis. and it's important that you stay up to date. So with that, you click on the update button right here, and then this window will pop up. All you need to do, just you need to make sure that you have this automatically check for updates at program startup. You want to make sure that this is always checked. This way, every time you open the program, and if there is an update, it will notify you, and it would be a quick process for you. Now, if you are one of our users who are stuck on build 2023 830, so that's August 30th, 2023, all the way to 2024 February 28th, 02.28. The feature to notify you of the availability of new updates, that feature does not function properly if you're on one of those or within this range. And what happens is that you wouldn't know that there is an update, even though we are issuing updates monthly. It won't notify you. So if you are affected, then you will have to do a one manual update. It's a one-time thing that you have to do it from inside. You can do it from inside Revit, or you can do it from inside ENERCALC or from our website. But it is a one-time thing that you would have to do, and then after that, everything will be okay, and it will start functioning properly. If you are on build 2024 March 4th or newer, so 0304 or newer, then this issue does not affect you and you are good to go. So you can update your ENERCALC in a very simple fashion. You just click on the update button right here from inside ENERCALC, and it'll pop up the same window that we talked about earlier. If you click on this button, this will launch the website page. So it'll take you directly to our website page, and you can click on this right here, which is click to download the Build 20 updater. So this is the one that updates your build of the software. So once you click on it, you take it, you update it, and then you run it. Once you run it, you're good to go. And of course, just come back and make sure that you're always having this feature enabled so you can be reminded of program startup. Another thing that we have here is that I want to let everybody know that currently we are on the October 30th build, so it's 2024.10.30. So that's where we at right now, and this was issued, or this update was released a couple weeks ago. Next, I would like to talk about registration for office hours. I encourage everyone to register for the office hours program so you can get email notifications directly to your email. Typically, the email address we have on file is maybe for an IT department representative or an admin that manages the office licenses. So a lot of times these notifications about the educational sessions never actually make it to the engineer and just stay with the admin or stay with the IT department. Or even sometimes go just one engineer and it doesn't go to anybody else. So that's why I encourage everyone who is interested in these monthly sessions to go ahead and register on our website to be notified. And of course, you can always unsubscribe as needed. And this is open to everyone, users and non-users. With that being said, you can register by, for example, scanning this QR code. You can just scan it with your phone and it will take you to the registration page. Alternatively, you can go to our website, enercalc.com/office hours. Very simple. And if this doesn't, if you don't remember the URL, you can always navigate to the registration page by just going to our enercalc.com, our standard website. You click for our users, and you click on get help and support, and then click on office hours tab or a button right here, and that will take you to the registration page. And again, the registration is simple. All you have to do is input your email address, your name. If you're an active subscriber, we ask you to give us your registration number, your KW number. If you're not an active subscriber, then don't worry about it. You can leave it blank, and you can finally just click on this button right here that says remind me about office hours sessions. And this way you'll be automatically notified before the office hour session takes place. The next part that we have here on the same web page, you can see more information about the next office hour session. This is always updated. So for example, today, if you go to our website right now, it says, the Wednesday, November 13th, that's the session, and the title of the session is ENERCALC for Revit. And you have the Zoom link. This is the most updated link. It's always going to be updated here. And you'll have the ability to add it to your calendar. So this will, if you click on this button right here, it will download a calendar event that then you can just add it to your Google Calendar, Outlook, Apple, whatever platform you typically use. Moving on here, if you scroll down at the same page, which is again enercalc.com/office hours, if you scroll down, you will see that we post all of the unedited recordings of the previous office hour sessions. And you can see here, for example, we have them categorized and titled. So in here, you'll see ENERCALC office hours recordings 2024. In a couple of months, you'll start seeing the 2025 grouped separately. And the last one we did was on October 9th, and that is the wood shear walls, the wood shear wall topic. That was the topic. So you can always, click on any of these and watch it on your own time. I find these to be very useful, especially for younger engineers who, if you're a senior engineer assigning work to a younger engineer, and let's say you want them to design a wood column, you can always tell them, hey, there is this training about wood columns. Go and click on this, watch this before you start pushing buttons and playing around. This way, they get a lot more robust understanding before they start performing calculations. Moving on to our next segment, what's new in ENERCALC? So last week, the ENERCALC team was at the NCSEA Summit that was held in Vegas. Many of the engineers we talked to were not fully aware of all of the new features we have introduced recently. So I decided to include a quick recap of some of the notable and latest features we introduced in ENERCALC. So first, I want to start with the decoupling of the IBC and the ASCE editions. Some jurisdictions started mixing and matching codes, so or design standards. So for example, they might be on IBC 2015, but they want to use ASCE 716. So they're not adhering to the reference design or the reference standards that the IBC shows or the IBC references. So we used to have the ASCE lumped up under the IBC that references it. So for example, if you're using IBC 2015, then ENERCALC will automatically grab the design standards that are referenced in the IBC 2015. That means ASCE 710, NDS 2015, ACI 2014, and so forth. But now, after decoupling the IBC and the ASCE editions, you can use whatever combination that works for you. So for example, you can pick IBC 2018 and pick ASCE 2022. Or you can say, okay, IBC 2015 with ASCE 716 or whatever combination you would like. This is also applicable to load combinations. Load combinations have always been decoupled, so you can always pick and choose whatever load combinations you want to start from, and also use your own custom load combinations. The second update is the addition of new ASCE 722 modules. We started with adding new tabs. So if you are on the latest and greatest, you will notice that in the add button where you typically go to get your calculations, you can see right here that we added these 3 new tabs. The first tab is the seismic loads, and we added a calculation for seismic base shear and another for seismic wall anchors. So you can do this right here. Next, the wind load. So we added another tab for wind loads, and we currently have implemented calculation modules for the ASCE 722 wind enclosure the envelope procedure, which is chapter 28, and the directional procedure, chapter 27. And currently, component cladding design or pressure determination methodology for chapter 30 of the ASCE is under active development. And once it's done, it will appear right here under this tab as well. The last tab we added is the Other Loads tab, and this currently includes a calculation for ASCE 722 live load reduction, but also will have some other calculations such as the snow load, snow drift calculations. One of the most requested features is the ability to automatically link reactions from one calculation to another, and doing all of this natively within ENERCALC. And having that dynamic reaction that allows the user to change something in maybe a beam and push one button and have the effects of that change trickle down all the way to the supporting members, such as a girder or maybe another transfer girder and so forth, or columns or all of that. So this is definitely one of the most requested features, and ENERCALC just has done just that. That is our new feature, which is called load linking. So when you open ENERCALC, and if you're on the latest version, or latest build, you can see the new tab on the top, and this new tab right here, that's called Calc Order. This tab organizes all of your calculations based on the load path order. So once you link multiple calculations together, sometimes they're not in the right order, or you don't know, maybe you linked calculation 1 with calculation 3 and calculation 2 with calculation 5. So if you click on this will always rework them, so they will always be in that load path order. And that's why here you can see that this says beam 1, then primary girder, transfer girder 1, and transfer girder 2. You can link multiple reactions from multiple members at the same time, and ENERCALC understands the load path logic, and it always ensures that all the calculations are performed following that load path order. We also, here at the very bottom, we added load linking status badges to help you navigate the status of each calculation and understand the warnings a little bit better. And at the very top, you can see there's a new button here that's named Recalculate Linked Loads. This button allows you to bulk recalculate all of your calculations to ensure that they're, the most up-to-date reactions are being used, and their effects are indeed trickling down to all of the downstream members. So you can also see here we have a little sign, like a little green badge. And again, these are the badges right here. But as soon as you see this, then you would know that this steel beam or this calculation is bringing a reaction from somewhere else. So this is also another clue saying that, okay, well, there's a chain going on here. Also, if you click on the Calc Order tab, you can see we have a folder that says Load Linked Calculations in the proper calc order. So they're here. And if you had other calculations that don't have any linked reactions in them, you will see here that it says None Load Linked Calculations. So you can actually click on this to expand it and see all of the other calculations that don't utilize load linking. So this is also just a good organization here for you, so you can know at first glance what is going on with your calculation. So if you are inside the calculation, steel beam calculation, you can see here that we have a brand new tab that's called Linked Loads. And you can grab whatever reactions from whatever calculations you have in your ENERCALC project file. So once you click on Linked Loads, you can see right here that says from beams, and this one that says from columns. So from beams, this will show you all of the other steel beam calculations that you've already created in this project folder, and you can pick whichever one that you want to get a reaction from. And as you cycle through these beams, this 2D diagram, this free body diagram, changes to reflect what beam you selected. This is a good way to help jog your memory a little bit in case the naming was not descriptive enough, or you couldn't figure out which calculation is which. You can always take a quick look at the free body diagram here to jog your memory and to be able to kind of remember what calculation is what. And you can also see that the table right here below it, this table right here shows the supports. So if you have, this is support 1, this is support 2. If you have multi-span, then you'll have multiple supports. And it shows you the reaction that's associated with each support point. So once you click on whatever you want, let's say we want the reaction from, you click on that, then you get right here in the lower part, and this is to determine how you want that reaction to be applied to your current member that you're designing. So for example, if I want to grab a reaction from an existing calculation and put it on this beam that I'm designing right now, do I want that reaction to be applied at a point load in a specific location? Do I want it to be at third points? Do I want it to be at midspan? So you get to choose the application of that load or the frequency of that load, and then all you have to do is just click on the link load button right here. Once you click on that, the load will be linked. And you can see here at the very bottom is the linked reactions. This table summarizes all of the reactions that you already linked into this current calculation. So for example, you can see here the calculations coming from beam 1, which is this one, and it's coming from support 1, which is this support 1 right here, and placement, the placement method is 1/3 points. And you can see here that indeed the loads are applied at the 1/3 point. So overall, load linking is a powerful and intuitive tool that allows the engineers to create a smart and well-connected chain of calculations while minimizing the risk of transcription errors, as well as increase workflow efficiencies. Currently, the load linking feature within ENERCALC is supported for steel beams only. We want to hear from our users what we should support next. So load linking for wood beams is under active development right now. And when it's done, this means that you can carry reactions from a wood beam to a wood beam to steel beam, and steel beam to wood beam. So every new integration we add for load linking will be functional with all of the other previously integrated modules. So with that said, we have a survey for our users to tell us which module we should implement next. So if you remember earlier, you can grab reactions from beams, and there was another tab right here that says from columns. If you actually click on that tab, you will find the link to the survey right here. So we here at ENERCALC prioritize implementation of feature requests based on how many users requested. So that's how we picked, the development for the load linking of wood beams in wood beams as our next candidate for development. But as of today, we have not decided which one to develop next. So after wood beam module is done and integrated, then whatever the survey results tell us, we will go in that direction. So if you're interested in wood columns first or steel columns, please go ahead and cast your vote here, and so we can make the development of our software in the direction that our users would like. So if you go on ENERCALC's YouTube page and click on playlist, you will find a new playlist dedicated to load linking, and it's very simple and easy to follow. It's a step-by-step guide on how to use load linking, as well as understand the various workflows. It also explains the status badges in great detail to give the user a full, robust understanding of the capabilities. So the first video is just a full overview. The second video is a walkthrough of a short example on how to use load linking in real-life applications. And videos 3, 4, and 5 dive a bit deeper into all of the various functionalities. You can give this playlist to a new engineer or someone who's never done anything with load linking, and they will be able to fully understand and follow the instructions and best practices of how to use this powerful tool. Another housekeeping item here is our active subscribers can request a no-cost lunch and learn for their office. This can be an introduction to ENERCALC or discuss what's new in ENERCALC or showing, for example, how to use ENERCALC for Revit and all of that. So you can request a lunch and learn on our website, enercalc.com, and then go to for our users, then get help, and then request lunch and learn. And this is, again, a no-cost lunch and learn to our subscribers. And then once you click on that, it'll just take you right here and you can fill in your information and one of our staff member will reach out to you for further coordination. So this concludes my portion of the presentation today. The main topic of today's office hours is ENERCALC for Revit. This segment is presented by Seth Roseworm. Seth is a senior structural engineer, licensed PE and SE in the state of Oklahoma with a diverse structural design experience, working on complex projects such as the new hangar for Air Force One, Choctaw Nation headquarters, and the Oklahoma City Will Rogers World Airport terminal expansion. Seth is also a talented software developer and has been a part of the ENERCALC team since 2020 with expertise in developing and deploying both standalone as well as API integrated software solutions. He is the mastermind and lead developer of ENERCALC for Revit, which is a plugin that allows the engineer to design various structural elements directly from within the Revit environment without needing to go through the traditional laborious process of exporting and importing stick analytical models and fixing nodes and all of the pain and headache that comes with that. EFR creates an immersive design experience, allowing structural engineers better utilization of Revit capabilities, all while, of course, optimizing workflows and efficiencies. Without further ado, I would like to hand over the control of the presentation to Seth to walk us through ENERCALC for Revit.
All right, thanks, Mac. I'm going to go ahead and get my screen share going, and then we will dive into ENERCALC for Revit. All right, so let's start by just talking about the general concepts behind ENERCALC for Revit, what Revit integration is all about, and then we'll dive into some fundamental workflows, how the process works, capabilities, and so on. So the idea behind ENERCALC for Revit is to provide productivity enhancement for structural engineering teams who already spend a lot of their time working in ENERCALC for structural design, structural calculation, and working in Revit as the nerve center of geometry control, multidisciplinary coordination, and document production. So the idea behind ENERCALC for Revit is the schematic you guys see on screen right now, which is to basically start with your raw Revit geometry, easily launch calculations, interact with those calculations, and make design decisions in the environment that you're familiar with, and then progress into actually making design decisions and pushing information back to the Revit model in real time. So this workflow starts with a Revit-based interface when you install the ENERCALC for Revit add-in, the same environment where you would find your structure tools, your annotation tools, your collaboration tools. You'll find a new ribbon bar for ENERCALC, and this is where you find preference settings, element manager views to overview your calculations, color-coded slide-out legends to manage status and design completion, calculation launch and design option windows, the ability to actually generate your calculations on the fly from Revit geometry. So these calculations are actually created using what we call a one-click or a point-and-click launch process, where you just literally start by designating the physical element you want to create a calculation for, specify the type of calculation you want to create, and what this will actually do is begin to walk you through a launch process where you're actually taking advantage of real Revit geometry for things like support conditions, connective framing relationships, tributary framing conditions, a variety of information to actually build a complete replica in the ENERCALC calculation environment of the physical element that you just specified in the Revit model. So this opens up a whole variety of capabilities and productivity enhancements, including things like the ability to seamlessly move loads vertically through a structure, for example, from beam to a girder, to a transfer post, to a transfer girder, to another column, to a foundation, seamlessly inside the Revit model using physical model geometry, not having to curate analytical geometry on the fly, using the data that your structural engineering team has already generated to make your documentation look right, to perform your multidiscipline coordination, and so on. And then obviously, you want to be able to short circuit the process of transferring design information from your calculation environment back to your documentation. And so the ability to push changes on the fly from an ENERCALC calculation back to the Revit model in real time will shorten your design times, accelerate your work, ease the documentation process by cutting out manual work and manual transcription, as well as reducing the risk of errors. Now, because Revit is such a rich graphical environment, ENERCALC for Revit also gives you the ability to have a lot of rich visualization of your design process. That includes everything from color coded design status and warning statuses to tabular views of your calculations, two-way navigation between tabular views and the actual model so you can see which physical element corresponds to which calculation, as well as vice versa in the other direction, seeing which calculation correlates to which element if you want to navigate the tabular view or the model view. It's easy to see that correlation. Now, if there's one thing about a structural Revit model that never changes, that would be the fact that the model is going to change. And so when those changes do occur, you need the ability to stay on top of how those changes are going to affect the validity of your ENERCALC calculations. ENERCALC for Revit has a robust framework of monitoring systems that lets you be aware when critical geometry changes alter or modify the status of your calculation. And when those natural changes and evolutions do occur over time, you're going to have the ability to stay on top of them, know what changes have happened, understand why those changes occurred, and then go and take action accordingly. For example, when we see that a whole framing system has undergone changes, we can now go and use ENERCALC for Revit's easy regeneration or recalculation tools to address those on the fly. So everything you guys are about to see includes the same version support that Autodesk provides for Revit itself. So that's the current version and three historical versions for a total of four. ENERCALC for Revit uses that same approach. And so currently we support Revit 2022, 23, 24, and 25. It's usually in April when the next version of Revit drops. And so when Revit 2026 becomes available, probably this coming April, then we will eventually deprecate support for Revit 2022 and you'll see us release support for 2026. So let's go ahead and dive into some real workflows and see how ENERCALC for Revit works and what that workflow actually looks and feels like. So, like I mentioned earlier, the process of creating a calculation is about as easy as it can be. We're just going to say we want to launch a steel beam calculation on this example here. As soon as we do that, a couple of quick approval steps help us condition that calculation with things like span geometry and support conditions. And so what we see in the ENERCALC calculation is a geometric replica of this calculation of this physical element in the Revit model. We can interact with this calculation just like we could a manually built calculation. Um, we can make design decisions. We don't have any loading information on this beam right now because we sent raw geometry from the Revit model, but we can go ahead and manually create some load information via the Loads All Spans tab. Now we can start to look at our moment diagrams. We could look at our unity check information, and we can make a design decision that we actually want to see applied back to the Revit model in real time. So for example, let's move our section size from a W16 down to a W8 by 10. Now, when we go through the save and close process, this is not any kind of an import export. This is not a manual file exchange. This is just a real-time synchronization from a single button click. And what we see now is our W8 by 10 section size reflected back to the Revit model. We see the linear loads we applied to that element. We see the title that we gave to that calculation, all summarized here in the Revit model. Now, springboarding from a basic singular calculation to another common design challenge, I want to talk a little bit about groupings of elements. This is a common thing you run into in a Revit model where you want to be able to manage the design of multiple physical elements, but obviously you don't want to create redundant calculations that are very similar. So ENERCALC for Revit provides the ability to do this using what we call parent-child groupings or parent-child associations, where you can take a single controlling calculation and assign it to multiple physical elements in the Revit model. When you create that association, then all of those physical elements will automatically take on the same design characteristics as the parent calculation. So in this case, we saw all of these wood joists automatically move from their default 2x4 size to the 2x8, dictated by the parent calculation. Now, if we take that a step further, now that that parent-child association has been assigned, we can make a critical design change to the parent beam that manages all of those child elements in the physical model. We can go change the section size, for example, from a 2x8 back to a 2x6 or even a 2x4. And when we save and close, we'll be able to see that those size changes are applied not just to the parent beam in real time, but also to the child beams. And then we have real time awareness of the pass fail status unity check wise for all of those elements and not simply the parent beam. So, taking this workflow a step further, you may or may not have noticed that when I created that parent child association, I also ticked a box that says copy reactions from the parent beam to the child beams. So, what that means is each of the child beams that we assigned to this parent also reflect the end reactions from the parent beam analysis. And so that prepares us to go ahead and proceed directly into a girder design, for example, this header that supports all the corridor joists in this project. We can go ahead and verify that there is a connective relationship between the infill joists and the header, and we'll see that the reaction forces are automatically associated from the end of the joists to the girder as applied loads. And so this is similar to the load linking workflow that Max showed a moment ago, except that this is occurring um, seamlessly and intuitively on the fly using spatial connective relationships rather than having to manually associate things. So, those two load linking examples that we just looked at a moment ago, the infill beam example, and then linking those from a beam to a girder, assume that you're in a situation where you've already gotten the chance to do infill beam design. But if you're very early on in a project and you need information quickly, or if your infill elements are manufactured products where you're not going to do an ENERCALC design, you may find the need to quickly generate results for a girder without having infill beam reactions that you can link. ENERCALC for Revit gives the ability to do that on the fly using what we call the girder point load generator. And so, for a situation like this hip roof girder that we see at the end of the building, rather than having to approximate this as a trapezoidal load, which would still require a lot of manual calculation, we're going to use the girder point load generator to generate real reaction forces that would apply to this girder using the tributary width geometry and the span geometry of all the infill joists that frame into this girder. So there's no deck and area loads on this particular roof area of this framing system, but we could walk down this list and see the physical joists, and we can go ahead and key in the magnitudes of area loads we want to use to generate reactions on the fly. We can copy that down and use it the same for all, generate those reaction forces, and now what we have is physical point loads in the Revit model at the appropriate span relative locations representing each of the joist seats where these infill joists connect to the girder. Now we can proceed directly into the calculation for the girder, launch that calculation just like we did a moment ago. And when we do that, what we'll see is a perfect ENERCALC calculation replica of that hip roof girder, the actual slope distance node to node from the start of the beam to the end of the beam, with all of those point loads automatically associated to the appropriate span relative locations without needing to manually calculate the point loads and without needing to somehow snap dimensions along the slope distance and skewed distance of that beam to find out where they should be applied. So, continuing to add to these workflows and take things a step further, let's go ahead and turn our attention to load paths. So, we did some simple linking from beam to girder just a moment ago, but we can continue to extend these workflows to multiple layer framing systems. For example, where we have infill joist, we have girders, we have beams, we have transfer girders, and now this all ties into a column. And so, with this column load situation, we can go through a similar workflow and go ahead and launch a steel column calculation, again, taking advantage of Revit geometry on the fly to build that calculation. And so if we go through the launch process for a steel column, we'll see a similar launch window to what we saw for the steel beam. The most notable difference being that for a column, rather than building span geometry, we're building a column slenderness profile. And so we're looking at slenderness about the XX. We can set a K value. We could specify overall height, or we can use the Revit model to infer on the fly what our bracing conditions are by physical intersection. The same about the y-axis, we can specify a ky value. We can ask ENERCALC for Revit to show us the most plausible bracing points for slenderness. And we can even see tributary relationships for connective situations where load is going to be transferred. And so when the steel column calculation loads, we can go to our 2D diagram and see we have two different levels in the building, the top of the column and approximately mid-height of the column, where three different sets of point loads are being transferred because of those three girders that tie into this column. We can look at our calculations. Just like we did before, we can make design decisions, things like changing section size, watching our results to see how they respond, whether that be a 6x6, an HSS 8x8, what have you. As soon as we make that design decision and we're ready to save and close, we'll be able to easily push this section size change seamlessly back to the Revit model in real time. So instead of having that extra step in the process where the engineer makes markups, hands the markups to a junior engineer or a BIM technician, instead we're able to make that change seamlessly and intuitively as part of the design process. Now, obviously, the ability to tackle gravity load path and the ability to handle columns also opens the door for really interesting situations. For example, transfer post or transfer column situations like we see here, where we have a girder into a column, perform the column design, and then we can perform design for the transfer girder, which underlies. And we can manually specify support conditions in order to clarify and make sure we get the exact load transfer that we're interested in. And so as we go ahead and get into this calculation, we can see the point load, which represents the axial force in the column transferred to a vertical demand at the midspan of the transfer girder, all seamlessly transferred in real time rather than having to manually carry from one calculation to the next. So increased speed, increased accuracy, increased ease of creating these calculations rather than having to measure and manually build each one of these. And now, because of the spatial relationships and the adjacency and proximity that we have going in the Revit model, we can go ahead and continue to extend this workflow into foundation design because we have a connective relationship between the column and the general footing here. And so if we go ahead and launch a general footing calculation, we'll be able to see in the same way we have all of our uh, footing geometry. For example, the default 4 foot by 4 foot footing, we can modify that geometry to make sure we're passing our bearing capacity. We can look at our rebar inputs and begin to modify the rebar that we want in each direction at the bottom of this footing. In this case, we're going with 6 No. 6s. And then when we save and close, we'll be able to see that ENERCALC for Revit is actually making open-ended geometry modification on the fly on our behalf rather than having to manually toggle. And there's a couple layers to that. If we go to the foundation plan, we'll also see that we have the ability to tag this information on the fly using Revit native parameters, which can be shown in either tags or schedules, and all that information is pushed seamlessly back to the Revit model in real time. Now, obviously, the open-ended geometry modification is a lot more interesting than a simple situation like AISC section size, where you're simply toggling on the fly. ENERCALC for Revit gives you the ability to either specify a size that already exists as a type within the family you're using for this foundation, or if a type of the proper size doesn't exist, can be generated automatically on the fly when you perform that save and close operation. So again, shortening that feedback loop, using the real geometry in the Revit model, and accelerating your documentation process to do the same work that your team does, but do it faster and more accurately. So all of those early examples we looked at were in that low roof area of the building where we didn't have any deck, we didn't have any area loads because there was no deck present in the model. And even if your structural team has never worked with Revit area loads before, it's definitely worth taking a look just because of the productivity enhancements you can get as a result of that. So we're going to turn our attention to the second floor area of the building and take a quick look at some Revit area loads and how we can do infill beam design and even girder design, taking advantage of Revit area loads. So if we go ahead and toggle the visibility so we can see the area loads that are present on this second floor, got a couple different areas of the floor. We have a storage area and then a typical occupancy area, which is just loaded at 80 PSF live and 35 PSF dead. And so if we were to grab one of these typical interior beams and launch a calculation for it, what we would see in the ENERCALC environment is that this beam comes in already loaded with a linear load, and we can see that it's broken down 35, 80, 7 feet of tributary width is automatically detected on the fly from the Revit model because of the real geometry that your team has generated. Now, that was for a simple interior beam, but we can also look right next door at this beam with the mechanical chase opening. We can launch a calculation for that beam, and we'll see segmented loads, which represent the changing tributary width as we go from outside the opening to the opening and so on. We can also look at situations where we have a stepped and skewed linear varying slab edge with a discontinuity, and we'd be able to launch a calculation for that and see trapezoidal loads, linear varying loads with a discontinuity in between. You can do the same thing, for example, on a beam that falls at the boundary between a more heavily loaded and more lightly loaded area of the floor, where in this case, we're going to see these loads broken down as two individual line items, one which represents the tributary effects of the more heavily loaded floor on one side, and then one which represents the more lightly loaded area. We can also look at loads that vary span by span, for example, on a canopy beam, which has a backspan at occupancy loads and a cantilever at canopy loads. And in this case, we'll be able to see that we have it broken down with our 20 and 20 at tributary width on the cantilever and our 35 and 80 in the other location. So speaking of second floors, it's worthwhile to talk about composite beam design, since that's another extremely geometry intensive design process, and one which takes advantage of a lot of the physical information in your Revit model, including span geometry, effective width, and many other things. So I want to briefly just talk about steel composite design within the context of ENERCALC for Revit as an example of combining area loads, floor geometry, beam geometry, and more. So ENERCALC for Revit gives you the ability to manage design properties intuitively right inside your Revit model. In this case, we're talking about things like editing your deck type. You can choose a deck type from a manufacturer profile. You can also set mechanical properties all across your Revit floor. And then we can also turn our attention to loads and actually set our sequencing using these simple checkbox parameters right here. For example, we have a live load that's post-composite only. We have a construction live load, which is pre-composite only, and we can set that accordingly with these checkboxes. And then we have a dead load, which is permanent, meaning that it's going to be post-composite and pre-composite. And once we've made those designations, we can proceed directly into a calculation launch, just like we would in any other scenario that we've seen so far. We go up and designate, we're going to launch a steel composite calculation, select one of these beams, and the only difference we'll see during that launch process is that ENERCALC for Revit is automatically detecting your effective width geometry for the composite beam on the fly. And so when we start to look at our calculations, we can see that our loads have come in sequenced exactly as we specified. We can also go and look at our 3D visualization for our effective width geometry that's been detected from the Revit model on the fly. And we can look at design decisions, for example, like calculating minimum studs, what our stud quantities are, what our reaction forces are, if we need to document those as part of our design. And we can even go to our framing plan and see where this information can be exposed using a tag. So we have an existing tag here, which we can toggle to an ENERCALC tag type. And this will let you actually seamlessly display on your plans things like end reaction forces, stud quantities, section size, and more. So that's kind of a natural segue into accelerating the documentation process, whether you need to document reaction forces only, whether you need to document stud quantities. If you're working with wood design, for example, let's say you have a multiple ply dimension lumber situation with a multi-gang dimension lumber, you can toggle that size and see via Revit parameters how that multi-gang section size is being designated, tag that on the fly instead of needing to tag it manually. Now that's using tags that actually pertain to design information, but you can also tag other supporting information if you're wanting to do calculation plans or various forms of coordination. All the titles and names that we assign to these calculations on the fly can also be exposed via tags or schedules so that you can correlate them between the physical model and a physical plan to your calculation package in a PDF. And one of the final things we're going to talk about before we wrap up and go to our Q&A today is just the concept of changes and change monitoring. So Obviously, if a Revit model undergoes a critical change, for example, removal of a support, you need to be able to be aware of that and undo that if the change was unintentional. But if that change was intentional, you do have the ability to keep that change and place appropriate warnings on the affected elements. For example, in this case, a girder support was removed. Now the girder calculation needs your attention. And this is also true of more subtle changes. For example, moving an adjacent bounding element, which then alters the tributary width of a designed beam. This is also true of more broad scope global changes like changing an area load on a floor. Changing that area load magnitude then causes broad scope warnings across many elements that were affected by that area load. It's also true of cascading load path situations where if you make a change near the top of a load path, then similar to the native load linking workflows that Mac demonstrated earlier, you'll be able to see warnings cascade down the load path, stay on top of what changes have occurred. And this is true also of modifying parent-child relationships. So for example, if you edit existing parent-child relationships, remove existing children from that list, that will remove the associated reactions. That'll allow you to see warnings on the girders which supported those reactions. And the same is true of pushing changes from your ENERCALC calculation environment back to the Revit environment in real time. For example, changing a load magnitude, which changes the reaction force, will then result in cascading warnings to the supporting elements. Now, when those changes do occur, you obviously have the ability to open that calculation for editing and go all the way back into the calculation view like we were before, but you also have the ability to regenerate and recalculate on the fly. So for example, we're going to look at an interior beam right here where we can open the calculation report and see that we have a W16 with a 0.57 unity check. And if someone on the engineering team were to make a change to this beam, for example, just manually toggling the section size from right here in the Revit model, we would see a warning status on that beam. And then we'll be able to actually regenerate or refresh that beam calculation on the fly by simply using the recalculate control natively on the ribbon bar. And so ENERCALC for Revit will call out to ENERCALC, get you updated results for that beam, and then you'll be able to go back to your element manager, retrieve the calculation report on the fly, and see the new information for the design of this beam, which is now W14 with a 0.76 unity check. Now that was a single element example, but you can do the same thing in broad scope, multiple change situations where you have many changes that have occurred. You can actually preview the load path that ENERCALC for Revit uses to recalculate these elements on the fly. And then you can trigger a bulk recalculation that will actually execute those recalculations in the appropriate order, which preserves the load path, starts at the top of the load path, recalculates the elements sequentially, and then provides you with a summary of results based on that recalculation at the end. So with that, I want to go ahead and toss it back to Mac for some open Q&A with the audience. We're going to go ahead and go through the questions that you guys have and any other questions that Mac wants to cover.
Seth, thank you for an informative presentation. We got a few questions here about ENERCALC for Revit. So let's kind of dive into some of those. So one of the questions that we got is that they say, do I need to apply the loads directly in Revit, or can I apply them in ENERCALC? And this is kind of a little bit more towards the idea that a lot of people are not familiar with how to apply loads inside Revit, and also they really don't want to be messing with that. So what do you think about this?
Yeah, great question. So ENERCALC for Revit, fundamentally, because it's designed to be a productivity tool that helps you do what you already do and what your team is already familiar with, is designed to have complete interop with Revit loads and have complete flexibility for you to send raw geometry from Revit, for example, send a beam with no loads and create all of your loading information in the ENERCALC interface the same way you would a manually built calculation. So the answer is yes, you can absolutely do either one of those workflows, meaning you can use load generation capabilities, you could use native Revit load capabilities and send an element with loads on it, or you can launch an element with no loads whatsoever and only get things like critical geometry, material properties, and so on into your ENERCALC interface, then create your loads in ENERCALC and proceed with your design accordingly.
So yeah, so pretty much with it's a two-way operability. If you're familiar with applying loads inside what you like to do, by all means. If you just want to stick to what you already know, which is how to apply these loads from the ENERCALC environment, then all you need to do is just apply them from ENERCALC, and then these two talk to each other constantly. So another question here. Um, that we have is about the geometry. So the question says, can I edit geometry in ENERCALC and push the geometry updates to Revit? So this is kind of go back a little bit um, to the two-way operability. So are there any limits to that geometry wise?
Yeah, for sure.
Yeah, so what do you think about this?
Yeah, so this is a great question, and it's important to keep in mind the precedents and what's the source of geometry control for your design. So in the case where you're working with Revit driven design, Revit is going to be considered the source of truth and the source of all your geometry control. And so for things like a multiple span beam or a simple span beam with a set span length, a column with a set column height, things like that are going to be driven by the geometry of your Revit model. And so you don't have the ability to launch a column calculation where the column is 25 feet tall and then alter the column to be 27 or 30 feet tall. The reason for that is because it's not clear to ENERCALC or Revit, the add-in, what changes should be applied back to the Revit model, or is it safe for a third-party add-in to change a structural model at all? And so for that reason, you would simply cancel that calculation, modify your Revit model to the way you want it to appear, and then launch that calculation again. Now, that's true for more global geometry things like how many spans does a beam have? How long are each of those spans? Does it have a free end or a supported end? Things like that. But at a more local scope, having to do with the geometry of a particular element, you absolutely have two-way control over that design. So, for example, changing the cross-section geometry of a beam or column from an HSS 8 by 8 to a W10 by 12, changing the gross geometry or thickness of a footing, changing rebar design parameters. And even in the case of steel beam, where the native steel beam family contains parameters that refer to the fixity of the connections. You have two-way interop over fixity of those connections, for example, from fixed, free, fixed, pinned, and so on. So some things are driven by the Revit model because there's no clear logic by which we could push changes back to a Revit model without jeopardizing documentation. But there are other areas where you have complete two-way control. Hopefully that answers the question.
Yeah, absolutely. And I want just to add one thing is that, geometry, column height, beam height, stuff like that, that comes directly from Revit and it's locked. However, something like a beam size, if Revit was, had a beam size modeled as a W8 and you went and you did your design and that had to be a W14, you can change this from within ENERCALC. You click OK or click Save and Close, and it will automatically update the size for you there. So that's another piece that I wanted to add. Our next question here is about it's about it says excellent presentation on vertical load path. Is there currently a capability to incorporate seismic loading?
Good question. So right now, obviously, you can incorporate the vertical effects of seismic loading because we're doing gravity design. And so if you're in a high seismic area where the dead load sees a modification from seismic load, you absolutely can incorporate that. But I assume that you're talking more about lateral force system analysis, lateral resisting elements, force distribution, and so on. So that's actually one of the first questions that we usually get from structural engineers when they see ENERCALC for Revit for the first time: how intuitive the gravity load path can be, how easily those calculations can be generated. Can we do this for lateral? And so hopefully in the near future, the answer to that question is yes. We have a number of different things that our engineering teams and development teams are working on right now to give you similar capabilities to what you guys saw today for things like lateral distribution from a diaphragm to resisting elements, future integration of lateral force resisting modules in ENERCALC, for example, wood shear wall, concrete shear wall, so on and so forth. So those things are not available right now. We have some of those things in beta testing with select groups of customers, and we hope to give more updates about that soon.
We have another question that says, where can I find how? Okay, so we have a question about, can the ENERCALC for Revit be used for masonry walls?
Yeah, so that kind of ties into that previous answer. ENERCALC for Revit, for those who aren't aware, is a relatively young product compared to ENERCALC itself. ENERCALC for those who don't know, ENERCALC was founded in 1982. ENERCALC for Revit was publicly released in April 2022. So a relatively young product, and all of those offerings are continuing to expand. Steel beam was our very first integration. Right on the heels of that came steel composite. Then we have wood beam. In the future, we're also going to have LVL and proprietary engineered, hopefully, capabilities as part of our wood beam. Now we have steel column. Now we have general footing. So the end game for ENERCALC for Revit is that you'll be able to seamlessly, intuitively, in your Revit model, launch an ENERCALC calculation for any physically modeled component that has an ENERCALC module counterpart. Obviously, those things are still in development right now, but we are getting close to the point where we want to start looking at things like lateral resisting elements, bearing walls, and so on. So those things are certainly on the horizon as we continue to add more modules.
Our next question here about and I just want to let you all know it's 3:04, so that kind of concludes the official time of the presentation. Seth and I are going to continue being here answering a couple more questions because we have quite a few questions. If you have another engagement and you'd like to leave, please feel free to do so, but we will continue being here answering some of our questions. So Seth, another question here says, where can I find how to install the ENERCALC, how to install ENERCALC for Revit?
Yeah, so ENERCALC for Revit is an add-on to your regular ENERCALC subscription. And so you would just reach out to support@enercalc.com to get with Jen at the business office, and she can assist you with adding ENERCALC for Revit to your regular ENERCALC subscription, just like you would reach out to her if you were going to add seats of regular ENERCALC to your pool of licenses, or anything like that. So once you add ENERCALC for Revit to your subscription, that automatically generates a delivery email, which goes out and you can do the installation, or you can go directly to our website, enercalc.com, on the For Our Users page and find the latest, greatest installer of ENERCALC for Revit at any time. Obviously, if you install that right now, before you've added ENERCALC for Revit to your subscription, you won't have the ability to interrupt between the two programs. But once you have that on your license, you can always get the latest, greatest installer in that way.
Absolutely. And as far as ENERCALC for Revit, once you reach out to us, we also do a presentation on onboarding that's a little bit more custom. So if you're interested, you can always request that at no additional charge, and you'll get a little bit more information on how to onboard your team, so you can use it effectively. So we have that already. There's another question, a little bit of out of topic. It's a little bit about ENERCALC, not necessarily ENERCALC for Revit, but I want to read it here for you and kind of get to it. So according to 2021 NDS SDPWS, shear wall capacity is calculated by multiplying the value from the table by 0.92 and then dividing it by 2.8 for ASD. However, when designing shear walls on ENERCALC, the capacity value always changes. Why is that? This is more of a support question, but I'm just going to try to at least shed some light on on this whole thing, because I'm not sure what you mean by the value always changes. I'm not understanding that part, but overall, just the 2021 code, the way that it's doing things, of course, a little bit differently. So you have, of course, the block and unblocked sheathing, aspect ratio, and then you have the new the new modifiers for ASD and LRFD. And then, of course, you have your load cases, and those will have, different adjustment factors based on, whether you're using wind or seismic. And of course, there's all kinds of footnotes for, for species of the framing material, which is, footnote 3 in the NDS or in the SDPWS. So I'm not sure specifically what's changing, but hopefully this kind of gives you a little bit of an idea because the 2021 version is kind of doing something completely new, unlike the 2018 and previous versions. So please send us this question to support@enercalc.com, especially with the ENERCALC file. And one of our support engineers will be more than happy to assist you to dig deeper a little bit into this. And
Yeah, it's also
yeah,
worth mentioning that we did have, I believe it was the October office hours just last month
yes,
was entirely dedicated to wood shear wall, and there is a recording of that for reference if that's helpful to you. And then, yeah, if you need to dive deeper, 100% be sure to
correct.
reach out
Yeah,
to
and the
support@enercalc.com.
That's correct, yes. And the Witcher Wall office hours that we did last month uh, didn't jump into a lot of the 2021 changes. So still, please, send us if you don't find your answer there, please send us your question to support@intercolleague.com. But the next question is definitely something covered in that office hours. So, and I'm gonna answer that since I did the office hours last month about the Witcher wall. So it says the newer version of ENERCALC shows maximum tension in the chord member as well as hold down force at anchorage for shear wall design. Shouldn't these two values be the same, and what is the difference between them? Yeah, this is something that we discussed a little in greater detail during last month's office hours, and I'd recommend you to go and because we have them recorded and posted on our website. So please go take a look there for more information. But to give you an idea or give you closure on the issue is that, and this is an engineering preference, some engineers do not take the weight of the wall as something that would help you resist uplift at the anchorage level or at the at the hold down level. And some engineers like to optimize a little bit more and take the weight of the panel. So the way that ENERCALC does it, when you do your calculation, it calculates what's your tension, what is your maximum tension in the tension cord member. So that would be a number. Let's say that's 2 kips, for example. And that's part number one. That's what the cord needs to be designed for. However, if you go into the anchorage, what ENERCALC does is that it takes that 2 kips and says, okay, well, you have a shear wall that's 10 foot wide, or so it takes half of that wall and the weight that you input for self weight. For example, if you put, I don't know, maybe 8 PSF self weight, and if the wall is 10 foot wide, so it says 5 feet, that's a tributary width to it, 5 feet times 10 PSF, that is, and of course times the height, that is the weight that's going to accumulate at the very bottom of the panel that technically could help you reduce your uplift. That's dead load. So that's why the anchorage force will be different than the chord force. However, you do not need to follow that, and if you're more comfortable just using the full capacity or the full tension force on the cord, then you can just simply design your hold down for that force and just completely for the anchorage. But some people do use it, and that's why we try to provide it. And your engineering judgment and make the decision as you see fit.
Perfect. Well, I think that was our last question, so that's a natural jumping off
Uh,
point for us to go ahead and give some information about next month and wrap us up. So, just wanted to thank everybody for being here, and I'll toss it to Mac to give us his final thoughts and a teaser for next month's office hours.
yes, next month's office hours gonna be on Wednesday. It's December 4th, 2024. This is the last session of the year before we adjourn. And the next session is going to be about general footing. So the general footing module, how to use it and give you a little bit of kind of some technical background and get you going from there. So please make sure you scan the QR code or go to our website enercalc.com/office hours and just register for the next session. That would be it.
All right, sounds great. Well, again, thank you all for being here. We look forward to these every month. Love to stay in touch with you guys. So be sure and catch us next month, and we'll talk to you then.
Thank you.